Hello everyone. Today we're going to talk about data pre-processing. Last time we talked about data ingestion. We learned how to read a training data set into the computer's memory, into a data frame object. And so today we're going to take that data, pre-process that data, and get that data ready for modeling work. So the first thing I'm going to do is I'm going to create a copy of my notebook from last time. So in my project folder, I'll just create a copy of my notebook. I'll change the name. I'm going to call it data pre-processing. Okay, so now I'm going to go back to my terminal, and as you can see, I have my data pre-processing notebook. So the first thing I need to do is to activate my environment. Remember, every time you come back and you want to continue working on your project, you have to activate your project environment. So vm scripts activate. This is where your activate script lives. And so as you can see, my environment is activated. And as you know, the reason I'm doing this is because for today's work, I'm going to need to install some Python packages that I don't have available on my environment. And so I want to make sure when I install those packages are installed in my isolated virtual environment. So this is my project directory. I have my input directory, output directory, virtual environment, and then this is my notebook from last week, and this is a copy of it that I just created. All right, so and this is what we did last time. We installed the pandas package. We used pandas to read a CSV file, and we looked at our data frame, and we spent some time, we did exploratory data analysis. And finally, we created two variables, capital X and capital Y. X holds our independent variables, and Y is our target variable or dependent variable. So basically, we want to use the data in X and hopefully learn how to predict Y. So for today's work, I'm going to use a Python package, Python machine learning package called scikit-learn. It's very commonly used by data scientists, so you have to make sure that you are familiar with this package. So this is my project folder, and again, this is a different terminal that I'm using. So I had my first terminal that I used to run my Jupyter notebook. This is a second terminal, and I'm using this one to basically, again, activate my project environment and start installing the packages that I'm gonna need. So again, I'm gonna do the same thing, vm script activate. I'll make sure this is activated. And now, basically, I'm going to run my pip install scikit-learn. So this might take a few minutes, and hopefully in a few minutes we should have a working version of the scikit-learn library ready for us to use. Okay, so we're back, and as you can see, I have scikit-learn version 1.0.2 and some other dependent libraries. Okay, so the first thing I want to do is to run a quick test to make sure that my package installation was successful, and kind of to verify that I actually have access to the package. So I'm gonna say import package name, which was sklearn, shift enter. I'm gonna run my notebook cell, and it's not complaining, which means my package installation was successful. If I didn't have access to the package that I just installed, I would get an error message, a module not found error message. I'm not getting any error messages, so I'm good. So now let's focus on pre-processing. There's different pieces of pre-processing that we could do on this data set, and it's going to be different for every data set, but this should give you a sense of what it looks like to prepare your data to fit into your machine learning algorithm. So if you look at column with index 1, this is our label. So every row in my data set is labeled as either having a label of M, standing for malignant, or B, standing for benign. This is a binary classification task, and so my labels are going to have two distinct values. In your data set, your label might be a single character, like in this case, it might actually be a string representing the classes, or it might be numbers. A lot of machine learning algorithms are going to expect you to feed your label as a set of integer numbers. For binary, it's typically 0 and 1. So the first thing we're going to need to do is to convert this. The first piece of pre-processing is to convert our labels into numbers, 0 and 1. It's not difficult to write a piece of Python code to do this conversion, but we just installed sklearn, and scikit-learn comes with utility kind of classes that's going to help us to cover most commonly used machine learning functionalities, including some pre-processing. And so what I'll need to do is to be a little bit specific and exactly tell scikit-learn which functions or objects I'm going to need to use. So I'm going to change my import statement, and I'm going to say from sklearn dot preprocessing import. We have something called label encoder, and as the name suggests, this is a label encoder. This is going to take your labels, which are strings or characters, and it's going to convert it into numbers. So I'll import this. So what I need to do is to create an object of the class that I just imported, and I'm just going to call it label encoder. So very simple. I'm just creating an object, an instance of the class that I imported from scikit-learn, and I'm gonna say this object label encoder that the function that I'm gonna use is called fit transform. And what I'm going to pass to this function is my label. So if you remember, my labels were characters. Now I want this to basically convert my labels into integers, and then I'm going to reassign it back to my label. So in one line, I can convert all my labels into numbers. And so this fit transform function, there is two parts to it. There is fit and transform. Fit basically means learn from the data what the integers should be. So in my data, I had two classes, M and B. So the learning part is called fit, and then the transform part is where it's going through my data, and it's actually one by one converting my labels into 0 and 1. And I'm reassigning it back to the same variable, y. Let's look at it. There you go. This is all my labels. As you can see, before I did the transformation, my labels were characters, B and M. Now it's all numbers, either 1 or 0. I can actually, just to help you see what's happening here, I can print my labels, Y, before I do the transformation, and I can print it here after I do the transformation. And so if I run my notebook again. This is what we're gonna see. So if you look at my original labels, my first label was M. Now it's 1. So all M's became 1 and all B's became 0. Okay, so everything is fine. I'll remove my extra statements to keep my notebook clean. I'm done with this piece of preprocessing. So we successfully preprocessed this column of data, our labels, and now they're nicely stored in this variable y, and this is what I'm gonna feed to my model. Now if we look at the rest of the columns, starting from column 2 to the end of my data frame, these are all numbers. Another piece of preprocessing work that we might want to do with a data frame like this, which contains all numerical data, is to scale the data. In a lot of machine learning algorithms, if you standardize your data, meaning that if you make sure that all your numbers are centered around the average of your data columns, then a lot of these machine learning algorithms perform better, so you could expect to get better results. So here in this video, our focus is not on the statistical reasons why we are doing this kind of preprocessing, but here we are just focusing on the preprocessing phase itself. So let's see how we can kind of convert all these numbers to standard scale. And one way to think about standardization is thinking about it as you're changing the unit of these data columns. We are not changing the reality of these numbers, the measurement that was done. We're just changing the unit. So it shouldn't matter if you state your weight in terms of kilograms or pounds, right? You're still talking about the same reality. Or it shouldn't matter if you're measuring length in feet or in meters, right? So it's the same concept. You don't change the reality, you are just changing the unit. And so it's the same concept here. If you're wondering why we are changing all these numbers, why we want to change all these numbers to a different set of numbers, even though we are changing these numbers, we are really, what we're doing is just changing the unit. So we are measuring how many standard deviation these numbers are from their centers, from their mean, and the meaning of the same is preserved. It's still the same data, and we're consistently applying it to every one of these values in our data columns. So we're consistently applying it to our data. Okay, so to get that done, we're gonna use some of these classes in scikit-learn. So again, from sklearn, scikit-learn comes with a preprocessing module. So from sklearn.preprocessing, we're gonna import a class called standard scaler. And as you can see, all class names are the first letters of the words in class names are capitalized. This is standard naming convention. So this is one of the algorithms that I'm going to use. I'm going to use a few other packages. While I'm here, let me add all those import statements. Let me kind of import everything that I'm going to need to use. Another pre-processing that I'm going to use on this data set is something called principal component analysis. So let me again import it from sklearn dot. This time this is in the decomposition module of the scikit-learn, and the class that I need to import is PCA. So one comment about these module names and class names, so you might be wondering if you need to remember these things. I mean, over time, when you work with a package, with a library like scikit-learn, you will automatically remember a lot of these names, but you really don't have to worry about it. Whatever you want to do, you can always check online and kind of do a quick search. Maybe just Google to see how you can apply PCA to your data set, or how you can convert your data set into standard scale, and you should get a lot of online help, which is going to tell you the sample code that's going to tell you what are the classes or packages that you'll need to import. So don't worry about it if you don't remember some of these names. You can always do a quick lookup, and either in your packages help documentation, or just Googling it online. So you'll know exactly what packages or what classes you'll need to import. So this is another thing I'm gonna use, but since we're gonna do a number of these pre-processing in a sequence, one nice pattern that we can use is to create a pipeline of these pre-processing. You might need to do multiple pre-processing steps, and so it's nice to create a pipeline and run the pipeline all together. So your data goes into your pipeline, and at the end of the pipeline you get your complete pre-processed data. So scikit-learn has a pipeline class that can help you to do just that. So I'm gonna say from sklearn.pipeline import pipeline. Again, I don't have to do this, it's just a nice pattern that I'm using here, and I can basically run all the steps in my pre-processing in one go. So I have all my packages, and it's complaining about pipeline not being available, and the reason for this is pipeline is with a capital P. So now I have my pipeline class. All classes start with a capital letter. All right, so all my import statements are ready to go. I've already pre-processed my label. What I'll do is I'll create a pipeline, and then I'm gonna add different steps in my pre-processing into this pipeline. So let me start doing that. Okay, so let me give a name to my pipeline. I'm gonna call it the classification pipeline. I'm preparing my data for a classification task, and so I'm gonna call this a classification pipeline because I can add my actual model training phase to the end of my pre-processing steps, and so data comes into my pipeline step by step. It's being processed and pre-processed, and when all the data is ready, I can feed it to my classification algorithm. So my pipeline, my final pipeline, will include not only my pre-processing step, but also my model training step. So I will have this nice pipeline structure where data goes into it, it's being pre-processed, and a model is trained from that data. At the end of the pipeline, I have a trained model that I can use to make predictions. So let me create an instance of the pipeline class. And what I need to define is a number of steps. And so it's going to be a list of tuples. And let's create our first element, our first step. So we have to give it a name. So it's just a string. It's a name that you give to every single one of the steps in your pipeline. So this is my first step, and one thing I wanted to do is to convert all my columns into the standard scale, right? So I'm gonna give it a name, standard scalar. This is the first step. It's a name, so I'll put it in single quotes. This is a string. And then the second piece is gonna be an object, a standard scalar object. And we already have a class in scikit-learn that's doing this for us. So all I have to do is to kind of create an instance of that class. That's it. I have a pipeline with one step in it. Data will come into this pipeline and it will be converted into standard scale. What else? I'm gonna create a second step, and each step is defined in a tuple, or some people might call it a tuple. Again, the first element of my tuple for the second step is gonna be PCA, or principal component analysis. And the reason I'm doing this, I want to compress my data, the 30 columns of data that I have, into a lower dimensional space, maybe convert it into just 2 columns. And so this is a data compression technique. And again, the focus of our today's video is not on the details of standardization or the details of PCA. There are entire courses on these topics. What we are showing here is how easily you can pre-process your data, but of course you have to learn about all these the statistical concepts behind all these different pre-processing steps, so you know when you would apply these techniques to your data. But for now, we are just showing you how to work with these pre-processing steps. So I'm gonna call it PCA, and similar to just what I did with standard scalar, I'm gonna create an object, and it's gonna be the PCA object that I imported, and I can actually pass some parameters to this. So one parameter that I can pass to this is the number of components, and I'm gonna set it to, it could be any number, I'm gonna set it to 2. Basically what I'm telling PCA is take my 30 columns of data and compress it into 2 columns. You would typically do this if the size of the data is a problem for you, and many other reasons. For this particular data set, it's just 30 columns. It's really not too much. I could run my algorithms without any issues. But again, I'm just showing you how to create different steps in your pre-processing pipeline. And once this is done, let's say this is all pre-processing that I want to do, the next step would be feeding this pre-processed data into a model and train that model. So let's start with a simple model. Let's start with a logistic regression model, which is a simple model. So first thing I'm gonna need to do is I'm gonna need to import the class that I'm gonna use for to run my logistic regression model. So again, from sklearn, this time I'm gonna import something from linear model. Logistic regression is a linear model, so it's gonna be under linear model module. So basically what we're saying is from linear models supported within sklearn, we want to use the one called logistic regression, which is the classification model. So I run this, no issues. Now I have access to this logistic regression class. So what I'm gonna need to do is I'm gonna go to my pipeline, and I'm gonna add one more step to my pipeline. So this is gonna be my model, and I'm gonna call it classifier. Again, I have to put it in a tuple, and I need to provide the actual object. So here it's gonna be logistic regression, and this is going to create an instance of that object for me. Okay, so I have my pipeline here. I'm just going to run this to see if everything is fine. So this is my first step, this is my second step, and this is my third step. Okay, so we had the syntax error, we fixed it, we reran the cell, and now my pipeline is ready to go. What I need to do is to feed my data to this pipeline. And if you remember from the previous video, there's two parts in my data. I separated my data into a dependent variable and a number of independent variables, x and y. Now this is all of my data, and what I want to do is to set aside some of my data for testing purposes. It's a best practice in machine learning to set aside a portion of your data and not touch it during the training phase, and use that new data that your machine learning algorithm has never seen before during the training phase. Use that data to test the performance of your model. So the ultimate test in machine learning is your machine learning algorithm must be able to predict on new data. And by new, we mean data that it's never seen before during the training phase. So how do we separate some of our data? How do we hold out some of our data and put it aside? So we had 569 rows. So maybe we can set aside 10% or 20% of it and set it aside for testing. 10%, 15%, 20% are common numbers for testing. Now to get that done, again, scikit-learn has a class that's going to help us with that process. So this time we're going to say from sklearn.model_selection import a function called train test split. As the name suggests, this is going to help us to split our data set into two parts, a test part and a split, kind of a train part. So I'm going to run this, make sure I was able to import this. And before I get to this, see how nicely packages are organized in scikit-learn. It's the one kind of machine learning package that I use here, and some of the packages are have classes for pre-processing, like the label encoder or the standard scaler. Some of it is helping me with dimensionality reduction. It's called decomposition. It's a name coming from linear algebra. It has to do with matrix decomposition. So it was named based on the statistical technique used behind the scene to do PCA. Then I have a pipeline which nicely puts together my pre-processing steps and my model building step. And then, of course, the whole purpose of this is to build models, so it comes with a large variety of models. In this case, I'm using a linear model, logistic regression, and it also helps me to evaluate my model, to split my data into train and test. So as you can see, it's covering all the phases that we talked about, all the phases of data science, pre-processing and model building and model evaluation. So now that I have access to this function, let us split our data before we before we feed it into our pipelines. Okay, so what I'll do is I'm gonna say train test split. Now I have access to this function and I can call it. And what goes into this function is, of course, our data set, which is now split into two parts, X and Y. And so this is going to be my capital X, this is going to be my capital Y, so my independent variables, and my label, or my dependent variable, or my target, and also a test size. So this could be 10%, 15%, or 20%, depending on your data size. So here I'm going to use 20% of my data. And so, and I can also set an optional parameter. It's called random state. And this is going to help you. You assign a number to it, but basically what it does, it's allowing you to produce results that are reproducible. So this 20% of data that's going to be selected for testing, if every time this data is randomly sampled from your data set, if everyone it's a different 20%, when you measure the performance of your model, because you are measuring it on a different data set, you are going to get different results. And so you need some consistency when you work with these algorithms, because you might want to come back and fine-tune your algorithm, and kind of you want to stay on the same data set, same 20%, to see if what you're doing is actually helping you to improve your performance. And you don't want to chase a moving target. And so when you define this random state and assign a number to it, any number, it will help you to basically stay with the same 20%. So over time you can track how your performance is changing. So this is going to generate 4 variables for us. So it's going to take our X variable and it's going to split it into 2 parts. One part is called train, the other part is called test. And so we have to do the same thing with corresponding Y labels. And so you're going to have the Y for, or the label for the train set, and Y for the test set. So this is going to generate 4 variables. And let us call these X train, X test, Y train, and Y test. So this function is returning back 4 values for you, and you can collect those 4 values here. So as you can see, scikit-learn is helping you to easily, in one line of code, prepare your data for an objective evaluation. All right. So now I'm splitting my data. My data is ready to go into my pipeline, and I've already defined my pipeline. So what I want to do is to actually run my pipeline and feed this data. So I'm going to say classification pipeline, which has all the steps in my model. I'm going to say fit. If you remember previously, we called the fit transform function on our label encoder, and we said fit means train, and the second part was the transform part, which was actually applying what it's learned to your data. Now you can call these things separately. So I'm just going to call fit, which basically means do all this work, but still don't do any prediction or anything. So just fit the pipeline. And what you need to do here is to give it your training set, which is your X train, your train variables, and your Y train. So I'll run this. Now this is learned the pipeline, and basically it knows what to do. If data comes in, it's gonna grab that data, it's gonna standardize the data, it's gonna compress that data into 2 dimensions, and then it's going to apply a logistic regression model to it. Now what we want to do is to test the model, see if we were successful in building our first machine learning model. So I'm going to say classification pipeline dot score. So this is a quick way to test my model. So your pipeline comes with a score function that allows you to quickly evaluate your pipeline. So you see how scikit-learn conveniently allows you to work with your pipeline. You define the pipeline, you learn that pipeline through the fit function, and now you run score on it, and this is going to give you the accuracy of your model. But accuracy on what? On test data. We separated our test data from our trained data. So what we need to do is to tell score that use our X test and our Y test and measure the performance of our model. So what score is going to do, it's going to take our X test data and it's going to make predictions on it, and then it's going to compare those predictions to the ground truth labels which we provided. And it's going to tell us what the performance of the model was. And this we can call accuracy. The result that we get from this, we can call it accuracy. And then, of course, we can print it. We can say test accuracy, and here I can say accuracy, and I can run this. So let me run my notebook. I'll run also. All right, so I'm just gonna run this one more time. There you go. Our accuracy is 0.947, which is really good. I mean, with very little effort, we built a model that's 94% accurate. So just a quick recap. We learned about preprocessing today. We used scikit-learn to cover most of our preprocessing needs. We created a pipeline. We added preprocessing steps to our pipeline. And then at the end of the pipeline was a classification model, a very basic classification model. And we split our data into two parts, a train part and a test part. And that was because we wanted to make sure our evaluation of the model performance is objective. So we don't want to show our data to the model and then use the same data that the model has seen before to evaluate how well it's performing. The ultimate performance in machine learning is prediction on new data, data that the machine learning algorithm has never seen before. And that's when we know the algorithm is actually learning patterns that generalize beyond the training data set. That's the whole purpose of machine learning. You want to train a model on some data, and you want that model to be able to predict on new data that it's never seen before. And that's when you know your model is actually generalizing. It's learned patterns that are true beyond your training data set. And so we fit this pipeline, and then we scored the performance of this pipeline. So basically, if I wanted to use this pipeline to make predictions on some new data, I could be 94%, over 94% accurate in my predictions. We'll stop here today. In our next video, we'll focus on the details of model building. So far, we've talked about data ingestion, data preprocessing, and I just showed you a little bit of modeling today, but there is way more details into the modeling process that I showed you here, and we're gonna need to spend some time on the modeling phase. So I hope you enjoyed this video, and I'm looking forward to having you in our next session.